Doing this, okay. So 59 over 600. So calculate this proportion, 59 out of 600. And then you got to press that convert to decimal, lovely stuff that you have to do, which I'm getting pretty handy at on this Inspire. Menu 2-1, menu 2-1, or I do menu 2 enter. And that works for me. So what is 59 out of 600? 0.1098? 0983? Okay. So a few people might say, well, there's about a 9% chance of you performing last, getting the vote. So, there might not be statistical evidence. But what we were just doing for this card activity, to connect to that is, could it have happened by chance? Instead of just, did it happen or didn't it? Could it have happened by chance? Is it possible that maybe there is an advantage to going last? So we have this statistical test that we're going to do. One big thing is called a p-value, and that's the whole goal at the very end. So I want you to put p-value down.
What's everything?
P. I don't understand either. But this is, the p-value is the way we're going to word it, not just p. We're going to call it the p-value. When we were doing the card activity, you did the probability, right, Brandon? And you found the probability where we were starting to get sketchy was around where? 2.5. About this? A p-value of around here. And I said we're going to try to look for values of something like this. Or 5% is kind of where people think, well, there's no way this probably happened in real life. There's no way that you could get 4 reds in a row. I mean, what are the odds? Or 5 reds in a row, or 6 reds. There has to be something wrong. We're going to use this little symbol called alpha. I think that second one looks a little bit better, like the alpha. Can't really see that? It's like the fish.
Anybody can.
A little bit better? I'm trying, but I don't know if that really works out the best or not. So our p-value is going to be something where we're going to be testing it and seeing. If our p-value is very, very, very small, the odds of this happening are pretty small by chance. So when the p-value is small, it's very rare that this could actually happen.
Where's the 2.5 coming from?
This is the one we were just talking about numbers that are where we start getting where we think this can't possibly happen anymore. This is our p-value. We're going to refer to it in a little bit and calculate it and figure it out. But when we were doing the card activity,
Is that 2.5 just like a constant?
2.5 is kind of like our benchmark. Like if it's below 2.5 or below 5%, we're going to start feeling like it can't happen by chance. Maybe you'll see when we put it all together. Okay? Because when we were doing the card activity, the first time, it was a 50% chance, right? Everybody still felt there was a lot of hope. We went to the second one, which is a smaller chance. And then as we got to the third red card, people were starting to lose hope. By the fourth red card, people were starting to think it's fishy. That was this percentage, this proportion, or this probability over here. It's like a probability of what we're trying to find. Okay? If the p-value is small, it's like very rare that this would happen. If it's large, we actually think it could happen. It's still possible. So I want to jot that down about your p-value, and this is how significant. Or your significant level. Or significance level. Sometimes we'll say, see if it fits with a significance level of 0.07. Most of the time, though, we're going to stick with these type of significance levels. And like I said, we'll talk about that as well. But I want to give you a little bit of background. This is basically a z-score.
So is the p-value the same as the significant levels?
Yep. Your significance level. we're going to be doing this z-score and finding the probability that this could happen by chance. That's all. The whole goal of this whole entire thing is to see if this could happen by chance. Or is this the way it is? And we know that there is we can either say that there's convincing evidence that there is an advantage or not convincing evidence that there is an advantage at the end. So our z-score, I'll give you the little formula. Remember how it used to be, we used to do z-score was actual minus what? Yep, mean or measured. What we're going to do here is we're going to do actual minus PO. And I'll tell you what that is in a minute. That is going to be kind of what you're supposed to get. And your standard deviation formula. Do you remember what you do?
Is that the...
Mm-hmm. Except we're going to use PO. So the whole chapter 9.2 and part of chapter 9.3 is really dealing with a z-score. But you have to put the right information in the right spot. And then we'll figure out what this all means in the end. So the probability or this proportion that we figured out from this sample, what did it work out to be? There was 59 of the 600 fans. Okay, so that's going to go in this spot. What was it supposed to be? 112. What's 112?
0833.
And we're going to do the standard deviation as if it was supposed to be. What's one takeaway that I'm thinking? 0.9167?
So PO is the expected value?
PO is your expected value, absolutely. Out of the 600 people? I kind of do this in chunks. I don't do the whole thing in one shot because I don't know if our calculators will be able to do it. So I usually just do the numerator and then I work on the denominator and then I kind of put them both together at the very end. So I would do the subtraction up above first. And then yep, we got this from the 1/12. This is from the 1/12. This would be the 1/12. This would be the 11/12. This is our n here. You just have to make sure that you square root that denominator first before you figure it out. Sometimes if you leave that off, then it throws the whole entire thing around. So what's the z-score? I got 1 point something different.
1 point something different.
1 point something different. I got maybe 1.33. Because we're going to be using, double check.
Cost.
You're going to be, in the back of the book, there's that Z, the table. We're going to be using that table over and over and over. I just kept flipping back and forth, back and forth. So if you have that paper handy, you might want to use that because it's definitely a good idea. So if Z equals 1.33, find the probability.
3.
So what did it equal, Caleb?
1.32963, so 1.33.
Okay, what was the Z? Did anyone look in the chart?
Oh, yeah, no.
I got 0918.
Point 90.
Oh.
Point
9082. Come on up and sit right up there. Okay, so let's see what all of this means. First of all, when we're doing this, we have two different hypotheses going on, or hypotheses. Put over in the corner HO and HA. Exactly. We're going to hypothesize. This one is the null hypothesis. This is the alternative. What are we measuring when we're doing this test? Significance of what? Like, in this actual problem, what are you measuring? American Idol contestants, what about?
Yeah.
An advantage to going last. Okay, what should be the result of going last? 1/12. Okay, so PO should be 1/12. Or we might want to put it in a decimal.
Where did the
Hypothesis.
We're doing a little hypothesis over here.
what is the second hypothesis?
A, HA, it's a alternative hypothesis.
So HO is like
HO is the original, what we're testing, or what we're thinking is going to occur. We'll do another little problem on the back as well, so that we can organize it as well and see. Alternative hypothesis is something other than this. But what we're trying to see is if there's an advantage. If there's an advantage, would they have an 8% chance or 8.3% chance? Would it be less or greater? Like this, kind of what we're checking to see. Do they have a more favorable outcome? Is it bigger than 1/12? So I'm going to change that with a greater than sign. So when I'm doing this, I'm trying to find out if it's bigger than or greater than that z-score. That z-score is 1.3. It corresponds to 0.9082. I need the part bigger than it. Let's hear it, Adam.
Wait, I have a question.
Mm-hmm.
Oh, so you do 1 minus that?
Why
Mm-hmm.
can't we write HO and then PO? Because they're the exact same thing. So they just have different titles. They're the same value, but they just have different titles.
This one is equal to, and that one is bigger than, greater than.
No, HO up top.
Yeah. These ones here?
Why is it HO equal to PO?
This is, I'm just listing it. Like, HO is going to be this, HA is going to be this. This is O and an A. Okay? So, the whole goal, let's hear it.
what's the name of HO?
HA alternative.
That's like, oh, I like names.